been around GNU Radio for a little bit, never had a chance to really go into things, but today we're going to talk about our exploration at New Systems. I'll talk about that in just a moment. Our exploration into GNU Radio, but also we made some tools that we thought would be useful. It's so easy to just dive into code and then forget about the tests, or to want to develop something and to leave the tests on the table, but we didn't want to do that, so we're going to talk about that today. So who am I? All right, so I graduated from Tennessee Technological University just down the road a few years ago. So I've done some software modeling of RF and RF and radars, things like that. I've gotten to work on more Internet of Things, research and development, and some communication systems development. And just kind of a fun tidbit, there's a theater not too far down the road called the Bijou Theater, and I've gotten to perform there with Irish dancing a few times. So if you guys happen to be in town for St. Patrick's Day, or you see Four Leaf Pete, the band around, highly recommend you go check them out. But also, who is New Systems? So we're a small employee-owned business in Huntsville, Alabama. Actually, recently employee-owned as of earlier this year, 100%. So it's really excellent. We do a lot of systems engineering. We do some RF analysis and systems analysis. We're currently expanding our expertise in hardware, and that's kind of what led us to GNU Radio and software-defined radios in general. And just real quickly, shameless plug, we are hiring, so we're looking for a variety of things to help us grow our expertise in hardware. So check out newsystems.com/careers. If you're looking for challenging work and a great workplace and a company snack room, we've got that. So today we're going to talk about what do tests look like right now and how do we go about doing some unit tests specifically. Then we're going to go to what we called New Radio. It was just too perfect. We're New Systems, it's New Radio, it's New Radio. So too easy for that. We'll go through a step-by-step example to kind of motivate what does this new test workflow look like. Along the way, we'll go through additional uses of what we think our blocks can do. We'll have a bit of a video of a hardware demo at the end, and we'll go through some future work. So first off, I want to mention, what are tests? Why do we need them? And at a very high level, tests are just, we built a thing, we want to make sure that it continues to operate the correct way. We want to make sure it works the first time, and 2 years down the line, it does the exact same thing. There are a couple different kinds of tests that you hear about. Some of them are unit tests, and those are what's available inside GNU Radio right now as GR unit tests. So generally, that's a small block of functionality, a unit, and we want to test that, make sure that it works. The actual size of a unit is subjective, but we just want to make sure that it works very thoroughly. And the idea is that if we check all of these individual units and then put them together into a newer system, then everything, because it was all individually tested, everything will just work. That doesn't happen always. So we have system tests that work on larger collections of these. Now what we're going to be working on today is a flow graph test. It doesn't really fall into one of these into these other categories. It's just a matter of whatever flow graph you make, we're going to test that. And kind of why? Why do I need to do this? And my coworkers laughing in the audience, because people like me love to just write features and write features and write more features. And it's fantastic, so much fun, and just I'll test it later. I'll figure out what happens later. And along the way, I'm like, oh, there's some code. I can optimize that, or I can refactor that, or yeah, I don't like that. I think I'm just going to rewrite it. So I do that the day before a demo because it's not going to change anything. Everything's just going to work. And it doesn't work. It doesn't work at all. And we have to go back and figure out what happened. And all of this could have been solved if we had some sort of test that we could develop quickly. Again, we're trying to do these things very quickly, trying to get them out the door. So it needs to be something that doesn't take a whole lot of time. But we need some kind of a test to make sure that our stuff still works. So that's kind of the reason behind what we're doing. But let's step through one piece at a time. So here we have just one block. If I want to test this block, what do? Well, let's go back to our definition earlier, where we are giving some known inputs. We're expecting a known output. And then you can see over on the right, we have what that might look like inside GR unit test, where we do the exact same thing. We recreate the flow graph, we give it some kind of a known input, we make the blocks, we connect them all together, and we run, and we check the output. Great. So what if we have two? Okay, well, that's still not too hard. Let's just update it with what we've got. We take our known inputs, we put the blocks there in the middle, and we check the outputs. And it gets a little bit longer, but overall, not super complicated. The issue becomes, how do I do the same thing with this flow graph? This is a BPSK receiver. Some of you might recognize it. It's almost the same as one of the examples on the GNU Radio Wiki for packet communications. But basically, we're trying to receive a BPSK waveform, depacketize it, and send some data out somewhere. But there's a lot of moving pieces in here. Each of these individually should be unit tested. But as a whole, how do I test this? Well, I mean, there's some ways we could test it. We could do the exact same thing we were doing before. We can take every block, define it inside Python, and run it. Or maybe we could do it kind of the smarter way in this case and just hit the convenient generate button at the top of GNU Radio Companion. And that would give us one time slice of what this flow graph looks like. But what does that look like whenever we make changes? Do we have to re-implement everything? Do we have to manually update things? Really, what it comes down to is, how do I test this? Well, I have a bad day, and it looks like my frowny face is off a little bit, but basically that's a lot of time spent for my day to figure out how do I test this, hook everything up, re-implement the flow graph in Python. And I'd really love if I could just test the flow graph that I made on the other side, the one I made in the first place. So that's where we introduce GNU Radio Test. Now, this doesn't replace GR Unit Test by any means, but it provides kind of a faster way to get into testing, and a way that's a little bit faster in terms of time. It doesn't take as long to make it, but also faster in terms of you don't have to learn this entire other unit test framework. You can use the existing tools inside GNU Radio Companion. So that was our focus. We wanted to focus on making the tests inside GNU Radio Companion and running the tests inside GNU Radio Companion, but also we're not having to re-implement all of our work from one flow graph into the Python version of it. We just use the flow graph that we made. Now, granted, it will be a little more limited than making our own custom tests, but maybe we can combine the two, and we'll talk about that a little bit later. Maybe we can combine the best of both worlds. So ultimately, though, I have to be realistic. Whenever I go from writing these tests, it doesn't suddenly make tests super fun and I'm excited about doing them. It takes me from being very upset about writing these unit tests to them being tolerable. And maybe that's all the difference. Maybe if I'm okay with writing tests pretty quickly, the test that exists is better than no tests. So let's go back to that example that we did earlier. Again, this is a BPSK packet receiver. And as we move along, we'll start adding blocks to this, and you can follow along in the top right corner and see what we've added. And also, I want to say a very special thank you to Barry Duggan, who has made so much work on the wiki that really helped us get started into GNU Radio. So really appreciate you. So first off, how do we test it? Well, let's take the first part. We said that we need to define some inputs and then define some outputs, and we want, for a given set of inputs, we want the outputs to work. So what do we do with that? Well, there's a couple things we could do. Sometimes maybe we don't want, sometimes we just want to use an SDR. That'd be great. But the problem is they're not repeatable. It's by default noisy. And that means if we run the same test 10 times, we will get probably 10 different results. I guess I can't rule out that it could randomly be the same, but we'll probably get different results. Or we could generate a perfect signal and pass that in. There's some benefits to that, but that still takes kind of a while. So how about we just take a file and we just record some input from the SDR or from whatever our generator is, save it to a file, and then run that. So that's what we're going to use for this particular example. That's not something new, but the new part is that if I want to do that automatically, let's say I want to run my flow graph normally with the SDR while I'm developing it, but whenever I start running my unit tests, then maybe I want to swap over to that file input. And that's where we start entering in the new radio test blocks, where we have the test enable and disable blocks. Basically, we'll get into more of the mechanism of how this works a little bit later. But whenever I run for tests and not just run for developing, then I can use this block to enable certain blocks, just like going over to the block, right-clicking and saying enable or disable, or using the hotkeys. I can enable and disable them there. They get moved out of the flow graph. And in this case, I'm actually using it to swap between using the radio and using the file source. So whenever I'm developing my test, I can just say, hey, whenever I'm doing my test, give me the file. That's great. So now, what do we do? There we go. So now, let's go on through the flow graph, just to the next stage. So like I said, this is a BPSK receiver. One thing about BPSK and any of the phase shift keying modulations is that they all lie on the unit circle. They should have an amplitude of about 1. So the symbol sync block that we had earlier, it relies on that, at least for this particular mechanism. And maybe we want to make a quick test to verify that our gain control, that's automatic, helps move it up, even if it's a very weak signal, help move the signal up to where we expect it to be. Maybe I want to make sure that the AGC is actually moving our signal level up to where I want it to be. So we made this block, this stream watch. So all it does is it sits and watches an input stream, as you might imagine from the name. And then it allows you to, anytime your signal goes outside of whatever bounds you give it, so it could be an upper bound, lower bound, or both, or maybe it's just you don't ever want it to cross a threshold. Anytime it fails that test, it will start writing outputs to a file, or at least tell you that there was an issue inside the console. This is a way that you can very quickly check instead of trying to catch it on a graph that you're using. It's a way that you can see very quickly if it fails, and something that we can kind of automate as a test. One thing I also want to say, we could also use this to measure like the settling time of the AGC, or we could use it to just in general measure signal level. Let's go ahead and move on. So after that, we've got our signal. We pass it through our clock synchronization. Now, whenever you have, I said earlier this is a BPSK signal. I used a QPSK graph here, but the example's the same. So you can see on the bottom right, it's really easy to tell whenever you've got a good clock sync. You have those 4 nice constellation points there, and you can tell when it's really bad, or you just have just about nothing in there. That's really easy for us to see with our eyes. If we wanted to write a script to analyze that, we could absolutely do that. It wouldn't take tremendously a long amount of time, but it's so much faster to just take a picture of it. So that was kind of the idea behind the screenshot block, is that just automatically, one time and then multiple times if you would like it to, you can take some screenshots just of your screen. Wow, it's an amazing concept. But it allows you to look at these plots in particular, and you can just visually see this worked or this didn't work. There are some other uses that we thought about that maybe you could use, including if you have a hardware status monitor. We'll get to why we were developing all these in a little bit. But if you have some kind of a hardware status on the side, like another configuration menu, you can record that as well as your data, so you can record what happened. And also, if you would like, one thing I thought of this morning is you could log user inputs. I don't know how many of you have messed around with a GNU radio flow graph and moved some QT ranges and decided, wow, these are the exact settings I need, and then you close it and then you forget what you had. And you have to try to recreate it. So an idea would be, what if we just take screenshots every couple seconds, and then whatever that setting happens to be, it'll be permanently recorded, and we can go check that out later. So next up, with all of these things, even screenshots that we're able to do, sometimes you just need more. You need a little bit more advanced functionality. So let's just write a script for that. That's kind of getting away from what we wanted to do with GNU Radio Test, but sometimes a script helps. So you're able to just hook this up, and then at the beginning or end of a flow graph, whenever you execute it, you're able to just run some other script or some other command. It's not super revolutionary, but it is very helpful for kicking off additional analysis or for doing some hardware setup. And we used a hardware channel emulator, and we used this kind of functionality to configure it before each run. We were able to run multiple times. And so we'll get to that a little bit later as well. But there's a variety of things you can do here. The sky's the limit, but that is not the focus of what we're working on with this. We wanted to keep everything, if possible, inside GRC. So let's go back to these other parts. Now, I just talked about we had a hardware channel emulator, and we used that last block, the run command block, to help configure it. At the start of every flow graph, we told it to change to a different set of parameters. But how did we do that? Well, that's where we introduced this variable change block. It's not super crazy what it does. Every time we run a test, it will take the next item in this list. In this case, I say it starts at 0 and goes to 10. That's just like a regular range. So it'll go 0 to 9. And then every time it'll make a new flow graph from each of those, and then it will set that variable to 0. And then next time it runs, it'll set it to 1. Next time it runs, it sets it equal to 2. Or you can set that equal to, I want to use QPSK this time. I want to use BPSK the next time. Whatever it happens to be, you're able to repeat a test if you want to, either using a different number or the same number each time. But that's really where the automated test portion comes. We're not just testing one thing. We want to test a variety of options. We want to test different features, or in this case, maybe we want to test multiple files. And so we can change the file every single time we run, just a different recording of the SDR. We can check different signal levels, different channels, all of those things. Now we need to kind of put everything together, because we could run the test, we could do whatever we want, but we want to make a descriptive name for it. And we'll see that'll be important. Whenever we run these tests and we save them, we use this name to kind of help you figure out which one is which. And there's a little bit more features that we can do. These help group all of the other blocks that we've developed into, well, by this test. And so you're able to, instead of manually enabling and disabling all of the different test features, you're able to just use these to kind of group them together and pick which ones run when. So now we get to the automated portion of the automated test. So we've just developed our flow graph, and we put things together, and now we've put in all of these other test blocks, and we could just hit run, and it would work. It would be fine. But maybe I want to run, like with that last one, maybe I want to change that variable over the course of the run. So that's where we have the test run tests. And there's a lot kind of packed into this one block. But essentially, it will take all of those other settings that we've configured. It will generate a new flow graph from each one, and then drop it into its own folder, and then run it in place. So all of the outputs, so the screenshots, and in this case, we have the console being logged as well. Anything like that gets saved locally to that test. That opens up a lot of doors where we're able to run a variety of tests. We're able to, say, tune a variable, or we're able to test out, like I said earlier, different channel conditions, and we're able to see, without having to manually change those each time and click play and then stop and then play and stop, it will run all of those for us, and then we can go right to that folder and see what the output was. So I think it's been pretty useful. It's also kind of helpful that it allows you to use embedded blocks because it's not just it's just using the exact same process as GNU Radio would. It drops it into that folder, runs grcc to compile it into Python code, and then it just executes that. So something that was also hidden in that block that I didn't mention is that sometimes we just run the block or the flow graph to stop after some amount of time. If I told it to run some automated tests and go, and I wanted you to run 10 times, it would run one time forever. So I need to tell it to stop. So what this does, it's kind of self-explanatory. It just stops the test. And this is wrapped up inside that last test, or inside that last block that we used. So overall, what did we change? We just tested that whole flow graph for a variety of things. What did we add? There's a lot of colors on here. There's a couple blocks that we added. But what I want to highlight is that part where we added 6 tests, 6 features for it, but each one of them only took 1 or 2 blocks for one, and some of those are just type conversion. So we were able to add quite a bit with very little work, and so that lowers that barrier to entry, that lowers that time barrier to maybe I would actually write a test for this. And I do want to say that most of those were written in GRC, or were implemented using GRC only, and not having to go to an external editor and write unit tests or external code. So there was one more feature that I kind of touched on but didn't really go that far into, and that is that define test. Whenever you make that name, you can actually associate each of the different features, all the different test pieces, to a specific test name, just using regular expression. So if I want to enable the SDR for certain tests, and I want to enable the file input for certain tests, I can use this regular expression, and all of the other ones will be automatically enabled and disabled per run, and they'll be attached to those names. And whenever it runs, it will take each of those names, drop it into its own individual output, and that way you'd be able to say, I want to go look at what happens when I change the channel model, go to that exact test, and then you won't have to worry about everything colliding with each other. All of it will just run as you would expect. So real quick, here's a list of features. I wanted to call out some of these don't require that you are using that run test block, and some other ones do. The run test block kicks off some other Python scripts, and it starts parsing the GRC file and doing a lot of stuff under the hood. But some of these features are just helpful, like running a command or telling the flow graph to stop at a certain amount of time. Some of those work just without any of that other process. So here, this was kind of the whole reason we did all of this. We were trying to test what happens whenever we have some communications waveforms, and we try them out with different channel conditions. We're trying to do very long-range communications in pretty harsh conditions, just generally being variable. And so one of the best ways that we need to do that was to get a hardware channel emulator and to use some software-defined radios. That way we could show not only ourselves, but show our customers that we've implemented things like fading, things multipath, all that kind of stuff. We're able to test all of that. And we didn't necessarily want to implement all of that. There's a lot of excellent hardware that does that for us. But we want to be able to run some automated tests to start stimulating that and change the channel for us, help us to test out all these different conditions in a way that that's easy, a way that we don't have to tell it to go every single time, and we don't have to spend 10 minutes setting the channel emulator by ourselves each time. So that's kind of why we did this. So we used an EDIS B210 and a TAS 4500 Flex channel emulator, this time using a QPSK communication. And what we were testing for, at least in this particular video that we'll get to in a moment, is that we just want to test that our clock was synchronized, and therefore maybe we could get some data. We'd also be able to tell a little bit about the channel, how good it was, or maybe we should just give up on that particular channel and try something else. So we have a quick video. I don't know if you're able to play that. You can see the TAS 4500 Flex channel model on the bottom there. And then this is a little bit earlier in the process. So we didn't have the run tests where you're able to just click play inside GNU Radio Companion. Do you know if you're able to play the video? It should be embedded in the slide. Thank you. So to be pretty quick, here I'm just kicking it off. Like I said, this is a little bit older. But here we can see that we have a QPSK waveform. We set up our channel to something that's nice and friendly. And so we're able to get very good clock synchronization there. We're going to flip over to something a little bit harder. And there you can see it starts to spread a little bit more. Again, this is going through a software-defined radio and through the hardware channel emulator. And then we have one more that we'll go to. And this one, I think it looks pretty funny. It's a big X. It means that maybe this is a bit of a harder channel. I'm impressed that it's able to resolve the 4 different sides of it. But yeah, overall, we're able to see here, using the same framework, we were able to develop some tests using our flow graph and then run them on some hardware. That was really the whole point for doing this. And let's see, there we go. Yeah, so just a quick review. So what did we make? Well, it's a test framework inside GNU Radio Companion. It supports some automation. I'm not going to pretend like it'll make all of the job easier. But it means that we don't have to leave GNU Radio Companion to implement some tests. And really, if you get creative with some of those other blocks, some of those tools, then you can implement quite a few. One of the big features of it is that it lowers the time that it takes to generate these tests. You can add 1 or 2 blocks and test some things. And it also lowers the skill requirement. You don't have to go learn GR unit tests or any of those other frameworks, and you don't have to leave GNU Radio Companion to start developing these tests. So especially for me, some of my coworkers are not as familiar with GNU Radio and Python, so I'm able to help them get ready for tests, make their own tests. It also reduces the code duplication that you have. Instead of taking your flow graph and re-implementing it in Python, and then anytime you make a change, going back and updating it again, it just does everything on the same flow graph. And we kind of envision this to be a complement to GR unit test as much as you can. So if there's a quick test that you can make, then hopefully that these tools help you out. If there's something really specific that you need, maybe the unit tests are a better way to do it. But we can test much larger sections. Now, where can we find it? So we have a GitHub that we set up specifically for this, which is super cool. Being able to open source this code. And hopefully it is helpful to you guys. I'd love for your feedback on it, or just what can we do with it. And finally, we have some future work. We weren't able to implement everything that we wanted to. One of them is that right now, whenever you change a variable, it will change it once and then run the entire flow graph, and then it won't change it again until the next time. We'd love to be able to automate, say, some user inputs on the Qt widget. We'd also love to be able to collate some of the outputs and put them together into kind of an automated report. Not necessarily a one-size-fits-all thing, but it would be very useful. So with that, thank you. Thank you for listening to me talk about automated tests. But do we have any questions?